International Association of Scholars. I'm Scott Turner, the regular host, and our topic today is going to be, let me just make sure I get the title right, Artificial Intelligence and ChatGPT. Should we be worried? And we have three very interesting guests today who will give us different perspectives on this. One is Barry Smith. He's a philosopher by training, and Jobst Landgrebe. He is a entrepreneur, tech entrepreneur, and computer scientist. And I introduced them together because they co-authored a very interesting book published by Routledge Press. Why machines? There you are. Why machines will never rule the world. Artificial intelligence without fear, and that should entice you to buy a copy of their book immediately. It's a very interesting book, and I recommend it highly. Our third guest is Steve Petersen, who is a philosopher at Niagara University in Buffalo. He describes himself as a tech optimist, but in a recent article in the New York Post, he has had his eyes opened and is a little bit more worried, I think, than the title of Barry's and Jobst's book would imply. And so we're going to have a very interesting discussion today. I'd like to welcome all three of you. And what we're going to do is we're going to start off with just a couple of minutes opening from all of you, and then we'll open it up for discussion in general. For the discussion, we go about 45 minutes just discussing amongst ourselves, and then we'll open it up to questions and answers from you, the listeners. And what we ask you to do is to please put your questions in the Q&A box. Of course, you're welcome to put it in chat, but it just makes it a little bit easier for us if they're in the Q&A box. And so with that, welcome Barry, Jobst, and Steve. And Barry, why don't we start with you?
Okay, so I started life studying mathematics and philosophy, and gradually became more and more of a philosopher. I worked for some time on the history of the philosophy of what is called ontology, which is on the one hand a branch of philosophy, and on the other hand an important part of computer science. I don't know if we'll get into that during the course of this discussion. Through my work on ontology, I came into contact with Jobst, who also worked on ontology for a time. And some 3-4 years ago, after a long pause, Jobst contacted me again, and he said he needed some help because he had been working very hard for some years trying to create powerful AI, and he had realized that there were certain crucial facts about AI which led to limits, which most people don't appreciate, and we wrote the book together, and that's it.
Thanks, Barry. So, Steve, why don't we go ahead with your opening comments?
Oh, well, so did you want like autobiography or sort of statement of position, or
whatever you'd like? I think that, well, if there's any parts of your biography that I didn't fill in, then by all means do so.
It's not, I mean, I also started in math and drifted into philosophy, just like Barry. There's a fairly natural channel there, to some people's surprise. And I actually started writing on the ethics of AI 20 years ago, which at the time was kind of laughable. It was like a smear on my record that why would anyone worry about AI? And now, of course, it's an entire field and so on. I've only been working on the so-called alignment problem, the problem of superintelligence, basically, for the past decade or so. But that's still a long time in these terms. And there, as you say, I started, I mean, as you quoted my editorial, I've always been a techno-optimist. I've studied AI because I had great hope and interest in it. And I originally studied the alignment problem because I thought they were easy responses. And the more I looked at the problem, the more I saw that the responses are not easy. And since then, I've been drifting more and more into the worried camp. And now, as timelines seem to have shortened considerably, I'm in the considerably more worried camp.
Oops.
Okay. Hi. Thanks for inviting me, Scott and Chance. So my background is in medicine, biochemistry, and mathematics. I was a postdoc until I was maybe in my mid-30s in the Max Planck Institute of Neuropsychiatry and Neurogenetics, where I worked in biomathematics and modeling natural processes using mathematics. Then I switched into private sector. But I've always, since 1998, worked on and with AI tools and made a living out of this all this time almost. And so I'm practically very experienced in it, but I've also done scientific research on it. And Barry and I started a collaboration, as Barry said, on AI in 2016. We wrote a couple of papers before writing the book, actually, also about AI. And I think AI is just applied mathematics, which enables us to either identify patterns or use patterns to automate processes. It's nothing more, nothing less. And we will discuss this at length, I guess, today.
Okay. All right. So just for the benefit of our listeners, Steve, I wonder if you could tell us what the alignment problem is, keeping in mind that most of us aren't immersed in this whole field.
Sure. Yeah, and of course, feel free to ask for clarifying questions. And also, I also would like to say thank you. Job's courtesy reminded me what I forgot. Thank you for inviting me. Yeah. So roughly, the alignment problem, like basically, the reason that many of us are worried enough to sign these letters. I actually just signed another letter today that's getting some press out of the Center for AI Safety case. I think the main premises behind this worry is roughly a relatively high estimate that superintelligence is possible, a relatively high probability that superintelligence was possible. Of course, my co-panelists, I take it, will disagree with that particular probability, but it's worth noting I think it's fair to say there's something of an outlier in terms of that. Most people, when it comes to the alignment problem, are confident that someday something like superintelligence would be possible. We can debate the timelines, but in principle possible, most people agree in principle possible. So you have that probability, and then you have the probability of, like, if there is a superintelligence, what's the probability that's going to be misaligned with our values? In other words, what's the probability that its goals, so part of intelligence, especially in this community and in the AI community, intelligence tends to be defined behavioristically in terms of roughly an ability to achieve goals. And so it builds in this notion of goals. And the question of alignment is, will these artificial intelligences have goals that are sufficiently like us that it would be compatible with us continuing to live and even being happy? And it turns out that basically it's really hard to imagine designing something from scratch that has human compatible goals. And you wouldn't think this, and I wasn't what I thought initially 10 years ago. And I think this is largely because of the power of anthropomorphization. We have our only experience with intelligences are intelligences like ours are humans. And so we tend to imagine that they'd have human-like goals. But it seems like, no, just about any goal is compatible. This is what Nick Bostrom calls the orthogonality thesis, that any goal, just about any goal, is compatible with a great degree of intelligence. And so, like, just as a kind of a simple illustration of the problem, early on in the days of these worries, early 2000s, an AI researcher had the serious proposal, when he heard about the worries, had the serious proposal that, well, we already sort of know how to make computers recognize human smiles, just have it be reinforced by human smiles, and then everything will be fine. And I see Barry smiling. He maybe knows this story, but if you think about it, if you really literally teach a machine to be reinforced by human smiles, there are all sorts of ways where that will go disastrously wrong in terms of what we actually value, right? So, for example, if what it really cares about is smiles, it will just maybe decapitate. There's not enough room for the body, so decapitate a lot of human heads, clone them, freeze them all into a beautiful smile, rictus. And it won't be doing this because it hates us or is mean or wants revenge. It'll be doing that because in this scenario, that's what we taught it to want. And it's very, 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 very good at getting what it wants. And so it turns out that, like, the alignment problem roughly involves solving ethics and then operationalizing it to the point where you can write it in Python. And that is just empirically turned out to be a really hard problem. So that's roughly the summary of why I'm worried. I think both those probabilities are high, so even multiplied together, they're still disastrously high.
Yeah, okay, thanks, Steve. I think you implied in there that these very troubling scenarios, they depend upon AI systems having a great deal of intelligence behind them, right? Whatever that is. So with that, Barry or Jobs, whoever wants to go first, you've argued that that kind of artificial intelligence is impossible, and I wonder if you could tell us why you think that.
You do this, Jobs.
Okay, so this problem of alignment is, from my perspective, of course, a pseudo problem. Why is it a pseudo problem? Because I disagree, and Barry also disagrees with your premises. So first of all, or antecedents. So first of all, it's not the majority of scientists who believe AI is possible. It's the majority of philosophers dealing with the problem, and it's also probably a tight majority of computer scientists, mathematicians, and physicists who understand what AI is mathematically, who really understand it mathematically, tend to disagree, and we are not part of a minority, but I think among mathematicians and physicists we are in the majority to believe that AI is in principle unfeasible, and we will also give reasons for that. But before doing that, the second thing is that why I believe it's a pseudo problem, because I don't think that machines can have values at all. Neither can they set themselves goals or have goals, or have ethical considerations, Wertgefühl, as Scheler calls it, which is a feeling for values. So I think that machines can have nothing of this, independently of the questions whether they can have consciousness or not. So because people like Bostrom says this doesn't even matter for them to become disaligned. But so we don't believe that machines can become super intelligent, or not even intelligent at all, actually. And I think we have also put forward a lot of arguments for this. And we don't think that machines can have goals or values in any way. And so therefore, I'm not scientifically concerned with this alignment problem, no matter how many people sign letters and actually, try to raise awareness of this. My personal view is that people who have invested in billions in AI, and I think, Steve, this is an argument that you should really consider, is that they are propagating this. They know totally that AI is not dangerous, but they do this to obtain regulation that protects their monopolies, because, as Peter Thiel says, competition is for losers. So they want to just maintain their monopolies and oligopolies. That's the evilness. That's what it's all about, and not at all about machines becoming intelligent.
So that's a very interesting idea that this is basically kind of a rent-seeking behavior. Before we go on to that, the assertion that this kind of super intelligence is impossible coming from machines, this of course turns on whether the intelligence that we have, for example, is so similar to the kind of intelligence that's being engineered by computer scientists or what have you. And that's not at all clear that they're the same. And I think, Barry, you've made some interesting comments about how so remarkably dissimilar human intelligence is from the kind of artificial intelligence that is out there. So I wonder if you could elaborate on that a bit.
Yeah, so just before this conversation started, I was listening to the beginning of a new podcast by Jordan Petersen. And Jordan Petersen is usually quite intelligent about minds and brains and emotions and so forth. But in this particular conversation, he was talking to an AI entrepreneur, somebody who I think did not understand about the mathematics of AI. And at one point, they were talking about ChatGPT, and they said, well, ChatGPT sometimes makes mistakes, and sometimes it repeats itself, and sometimes it goes around in circles, sometimes it hallucinates. And then they both agreed that it's exactly like the human brain. And then they were talking a little bit about neural networks, and they obviously had the idea. And this is against what Jordan Petersen has been saying in other contexts, that the neural networks in the computer are like the neural organization of brains. And in fact, neural networks, as Jorbs has already said, they're a piece of applied mathematics. They don't have anything to do with molecules or electrochemistry or all of the things that make the brain work. And so the conversation went on. They then said, and of course, it's clear that ChatGPT can now pass the Turing test. Now, if that was the case, we'd know already. We'd have lots and lots of people showing how ChatGPT is indistinguishable from a human being if you ask it questions. And I know I've tried it over and over again to get it to be indistinguishable from a human being. I have videos on my YouTube site where I illustrate some of these discussions, and it's completely distinguishable from a human being. It doesn't talk like, well, it doesn't emit sentences of the sort which a human being emits, or at least it's easy to make it not emit such sentences. And if it were to pass the Turing test, it would always have to be in a position where it was emitting sentences exactly as a human would. So then they go on to talk about how ChatGPT just taught itself 1,000 languages without any training material. And but then the most important thing that they concluded was, this was just in the first 10 minutes. Then I had to come away to talk to you here. Then they said that the hallucinations of ChatGPT, for instance, inventing articles to support views, that they are a sign of creativity. Now, so people fall into a position where they want to anthropomorphize this algorithm. Another thing they said actually was, and it could never be an algorithm. It's far too subtle to be an algorithm. But anybody who knows the physics and the mathematics of computing knows it's just an algorithm. It's a very simple algorithm. It has to be, because it has to be computable on a Turing machine. And it's just a very big, simple algorithm with billions of parameters. Now, that's nothing like what a human being can do with his or her brain. And you can see that if you look at ChatGPT in a more critical light, you can see where it deviates from the human brain. I wanted to say one thing about ethics, rather taking the devil's advocate. Let's suppose that Steve and his allies are right, and that there is a high probability of having an AI which is more intelligent than human beings and has an evil will. And then Steve says, well, the answer is obvious. We just have to solve ethics. The problem is that we have enemies. So even if we, nice people in the Western world, solve ethics, there's no reason to assume that all potential adversaries in the future will go along with our solution. And so it's, on the one hand, it's a lot safer than Steve wants to admit, but because it's so far away from intelligence, and we say it's infinitely far away from intelligence. But on the other hand, it's also much more dangerous than Steve is willing to admit, because even if we solve ethics, that doesn't mean that the rest of the world will go along with us.
Steve,
Scott,
yes. So,
yeah.
sorry, I inadvertently muted myself. So Steve, there's some interesting challenges for you.
Yeah, I tried to take, if you see me looking down, by the way, I'm trying to take notes.
Of course, we're all doing it.
So you're also saying, like, well, the majority of computer scientists and mathematicians don't think it's possible. I don't know that that's true. I mean, this is an interesting empirical question. I mostly I like to cite this one Vox article. I can try to link it in the chat if you remind me,
Mm-hmm.
where there's a survey of like AI researchers where over half of them, or sorry, 48% of them thought that their work had a 10% or greater chance of leading to human extinction. That's a terrifying statistic.
I say I agree. I said that mathematicians and physicists don't believe in it, while a tight majority of computer scientists believes it. And the reason they believe it is they don't know the mathematics of how it works. Okay. They're programming computers, but they don't know the mathematics.
So let's go to, so here's a couple maybe central points. One is like, does an intelligence have values? Now, there's a certain sense, I mean, I'm very interested in the question of whether AI has what you might call something like real values, and in particular, whether it might have ethical significance someday. But this is a straightforwardly philosophical question. I mean, it's a very hard question, but it's a philosophical question. What makes something of ethical significance? When does it have real interest? When does it have real values? But I think the values of interest for us today are very behavioral, in the same sense that like AlphaGo, you might say it doesn't really want to win Go. It doesn't really want to do anything because it's just an algorithm. But damn, it's good at playing Go. It will beat the pants off of any human. And in that sense, it's straightforwardly interpretable by its behavior as having the goal of trying to win Go. And that the behavior is what's relevant for whether the humans stick around or not. You know, it's no consolation if we're wiped out that like, well, it didn't really value the things it's doing. It's just doing those things. So what we're asking about is this behavior, and I'm seeing agreement from Jops and Barry. So I just wanted to make that clear that as interested as I am in whether there are real values there, whatever that might mean, there are algorithms can be quite successful at achieving goals.
But you said, Steve, and this is, I think, a very important point. You know, the computer can't want to win Go, and you know, this kind of wanting is an inherent feature of most living intelligent systems. It certainly is a feature of our own intelligence system. And for it to be evil, you have to have goals. And for there to be goals, these systems have to want to get to those goals. And that's also a philosophically very fraught question, especially in the sciences. So given that computers can only do what we want them to do, isn't the responsibility in our hands? You know, we're the ones who have the actual goals. Isn't the responsibility in our hands to define what the ethics of artificial intelligence is? And once we've defined that, then are we okay?
I have a lot of responses, if I may. So,
okay.
I mean, for one, so again, like you say, it doesn't really want to win. It's not going to be evil. You know, but okay, this is not, you know, if the philosophers somehow could say after the fact, like, well, it wasn't out of malice and evil that it wiped us out, that's very little consolation. I want to focus on the sense of goals where it manages to achieve things in the world, despite obstacles, despite even obstacles like other intelligent beings like ourselves. And so they're like, is it evil or not? Now you say, well, it can only do what we programmed it to do. This is an ancient objection. Alan Turing in his original paper calls it the Lady Lovelace objection, because Lady Lovelace is said to have said something along those lines. And I think that is a very, I want to clear up a misconception there, where like, you know, my students, whenever I teach this kind of stuff, they're like, well, AI are just programmed. And I try to beat the hell out of, beat that out of them, because there's this deep ambiguity in what it is to be programmed. There's a clear sense where AlphaGo was not programmed to beat every human. In other words, it wasn't told like, in this exact circumstance, do this, in this other exact circumstance, do that. Instead, it learned about developing all sorts of heuristics to play an excellent game of Go. And that's why it can beat any human in Go. So there's a clear sense where computers can do things that they weren't programmed to do. Now, when I point this out, students will retreat to, yeah, but it was programmed to learn, which of course is true. You don't think it was programmed to learn, Jobst?
No, it didn't learn. And we'll come to this, but
okay.
I mean, maybe if you finish first.
Well, yeah. So I'll finish that. But learning, again, like you might say, it didn't really learn. But look, on a behavioristic level, did it get better at Go from where it was before or not? Did it get better at achieving its programmed goal? Now, I'm agreeing the goal is programmed ahead of time, right? Or at least in a very specific way. But did it get better at achieving that goal? That seems straightforwardly true to me. But I think I'm guessing as a last point, the main question for this panel is like, are we just algorithms? at the right cognitively, at the level of cognition. Barry says AI won't be able to do everything humans can, and in certain senses, this again goes back to Turing, that you're not going to expect them to like enjoy strawberries and cream because they won't be embodied in the same way we are. So of course I would grant that at some level. The question is at the level of abstraction of like being able to make precise plans to achieve things that you've been hardwired to try to achieve. Are we just algorithms like the AI? What is it to really want? It might be that it's just an algorithmic state, that at the right level of description, we are mere algorithms. And if so, then AI is, of course, it's possible to make it like us.
So, I mean, I don't even know where to start, but maybe, and I'll hand over to Barry soon, but maybe just very briefly. So basically, what you're assuming is that an AI can become autonomous because because autonomy means that I can set myself new goals, or the machine can set itself new goals. And of course, we agree that if a goal is set by a human engineer, then the machine has no goal. It's just computing something towards this goal. And if AI would have to become would be able to change its goal without the human interference, then I agree with you. Then it could emulate something like the will, right? So, but for this purpose, it would have to reset its goal autonomously. Now, why do we believe that this can't happen? And why do we say that neural networks do not learn? So maybe to begin with, why can't this happen? So let's look at natural intelligence. Natural intelligence, we defined in the book, is the ability to solve a new problem that the organism has never encountered, for which it was never trained before, in a way, spontaneously and rapidly, in such a way that the organism has a gain from this, and so that this happens in accordance with the intentions of the organism. That's natural intelligence, according to Stern and Scheele, and also more modern definitions. And the alternative to this, which we don't mention in the book, is that there is already a solution to a problem, but you can find a better solution. Like there was maybe there was a solution to use flowing water as a transport means, but then the wheel was invented, which made it more flexible to transport something. Which was, and so this is intelligence. And we don't know how natural systems bring about this behavior. I wouldn't call it an algorithm, because in my definition, an algorithm is something that is made by humans, it's a techneon, whereas the natural intelligence is physeon, so made by nature. But no matter whether we call it algorithm or not, it is the result of the activity of a complex system which we don't understand. And now comes, before I hand over to Barry, the most important point. Oh no, 2 points. The most important point we make in the book is that we can't mathematically model complex systems in a holistic way. And so if we can't do that, we can always model partial functions of complex systems, like playing Go, or or playing chess, or creating sequences of texts like ChatGPT does it. But we can't model the overarching capability, because we can only create partial models of complex systems mathematically. And now the second point, and then I hand to Barry, is that what do we do when we create an implicit equation like the one running in ChatGPT? Well, we give the machine training material, we give it an algorithm to find a local optimum between to optimize a loss equation that is with which express the relationship of the input and output of the model, and then we can compute a derivative, or we set this loss function to 0. In the loss function, we have as one term the model itself, and then we do calculate a gigantic derivative to find a local minimum in this equation. So we do nothing else than numerically finding a local minimum to a very, very long equation. And this is not learning or training. This is just parameterizing a stochastic model. Yes, it's a very big model, and the process of parameterizing the model is iterative, so that this is not done in one go, but in several steps. And that's why we use anthropomorphic analogies like training and learning, but it has nothing to do either with training or learning, but it's just a parameterization. It's very elegant, it's very powerful, But in the end, it's just a very, very long equation with many parameters to compute a certain input from an output. If you change the slightest rule about how to go from input to output, or change the data, or do anything else that perturbs this, the system will immediately fail, and we see it fail all the time. And that's because it's not intelligent, but it's because it's just a parameterized equation. No matter how complicated it is, it hasn't learned anything. It is just being computed using a human-designed numerical optimization algorithm.
Okay, I'll take over now. So the places where we are most tempted to say that the AI has a will or has a desire, wants to win, are games. Games like Go, games like chess and so forth, first-person shooter games. And these all have in common the fact that we have a reward system, so we can specify exactly the value of a certain move in the game, and thereby we can build computer representations of what it is to play the game, in which we can have the computer play against itself millions of games, and thereby identify better, as we would put it from the outside, better strategies. In fact, the computer has no idea about strategies or games or winning. It's just programmed on the basis of millions of games which it plays with itself. We can only do that where we have a reward system where the rewards can be assigned by the computer. We can't do that with human conversation, even two-person human conversation, because there is no reward system for contributions in a conversation. And if you don't believe me, then try it with your wife. Work out a reward system for every conversational interaction and see how long it lasts. You can't do it. Now, one of the wonders of ChatGPT, and I've become obsessed with ChatGPT, I think it's fantastic, is that they found a way to build a reward system for human conversation. It's always a two-person or a two-party conversation, and it's a reward system which is based upon taking, I don't know, they don't release the exact numbers, but something like 40,000 very typical questions or prompts, which I understand are taken from Bing, having responses to those prompts be created by contractors in Kenya or India who are good at English, and they're told to write responses. And then these responses are evaluated by other human beings with a reward system. So responses which are really good get a high reward, and responses which are no good get a low reward. And then the system has a reward system which is based upon choosing 40,000 Bing prompts and then having, I don't know, 200,000 responses to those Bing prompts, which have been given as points score between 1 and 6. And then the computer can generalize, it can find patterns and apply this reward system to new prompts, which are not in the original list. And we can create those prompts all the time. And I do this all the time. That's my principal activity lately. And when we have prompts which are close enough to the prompts used in this reward system preparatory work, we get pretty good responses from ChatGPT. But I don't take prompts which are likely to be close. I go all the way out, way, way beyond what is in the heart of the distribution which ChatGPT is using. And I get constant hallucinations. If I'm asking about myself, for instance, I asked it to list the 10 most important publications. It listed 10 publications, all of which looked as if I might have written them, some of which were in a journal which doesn't exist. So I asked them, who is the editor of this journal? And it said, Barry Smith is the editor of this journal. So it invented a new journal of which I am the editor. And things got worse and worse. It invented a whole new valley system in Switzerland, for instance, and provided all kinds of tourist information, what you can see and the music and so forth. So it invents things more or less at random. This is not creativity. This is just a random energizer bunny, which is being set loose in all directions. And now there's no way in which you can have the kind of reward system which creates intelligent behavior which is systematically better than that of a human being outside a field like Go. As soon as you start to be more ambitious, and ChatGPT is amazingly ambitious, then you fail, because the reward system will work only for the heart of your distribution where you have lots of data. It will work well with Michael Jackson questions. It won't work well at all with questions about Frege. I know, because I checked. Mm-hmm. And it won't work well when it comes to creating creative uses of language. So I checked the Sopranos mimicking opportunity that you have with ChatGPT. You can have it issue a response to a query in the style of Tony Soprano. It's embarrassing. I can't describe it. It's so bad. No one would ever confuse it with any kind of human speech. It's a low-grade semi-human speech with bits of slang which were taken from Tony Soprano. So I am impressed with ChatGPT. I think it's an amazing thing. And I know people who are using it in their companies very successfully to do systematic summarizing, for which it's very good. But it's not intelligent. It's too easy to break it.
So if I understood what you were saying there, Barry, that what comes out, you can make these things hallucinate, as you indicated, and that depends upon the prompts or whatever, I'm not sure you're talking about, that they're fed into this. The what?
Prompt is the word they use. It's mainly questions, but includes also requests to perform certain tasks.
Okay,
with
all
language,
right.
or with computer code to some degree.
Okay. But somehow, whatever humans are doing with it, whether it's the 40,000 programmers and I forget where you said who are paid, Kenya, who are paid to put in some of the input data for how ChatGPT puts things. That can be, and the fact that you can make these things hallucinate, in quotes, says that we can actually make AI and GPT systems do things that's well, we can make them lie, just to put the matter bluntly, and this feeds into your concern, I think, Steve, as I understand what you're saying here, that okay, maybe with the niceties of brains versus programs and all the other kinds of things that go into it, there is a certain way it can be hijacked by evil players, and we may not even know about it. Is that a fair statement of what your concern is?
Yes and no. I mean, certainly there are any truly powerful technology will have sort of dual use risks, right? Mm-hmm. Where like it can be abused.
Yeah.
In some ways, for me, that's business as usual. We're used to technologies opening new applied ethical doors. Mm-hmm. I'm very interested in that. I think there are real risks involved, but I want to say I think there are real potential benefits to technology like ChatGPT. But my main concern is the probability of genuine doom from the kind of, not from ChatGPT itself, I should emphasize. I mean, for one thing, I want to agree that like autonomy is an important thing. I wouldn't agree with the way Opsput defined autonomy. It's easy to have a program rewrite its final goals. So that's clearly not sufficient, but sure, I could just like have it try to find something that'll hash to 1, and then every 20 seconds try to find something that'll hash to 2 instead.
That's not autonomy. It's
okay, but then now we're talking about what autonomy is. But you see, the point is like, I mean, yeah. So you, of course, anyway, this is a more extended discussion. But the point is, often when we try to find disanalogies between humans and algorithms, we hold a double standard. And I think it's important, that like it's quite. I mean, I'm roughly with Daniel Dennett in terms of like we are just algorithms, and our creativity is just remixing all the stuff we've absorbed in the past. And because we don't recognize all the sources, just like GPT, that's all creativity is. It's like not recognizing that I'm doing 10% Picasso 15% Van Gogh and whatever percent Rembrandt when I create something. But yeah, I mean, so sorry, your narrow question was about what we sometimes call short-term AI worries: autonomous vehicles, autonomous weapons, misinformation threats from large language models. These things are very serious for sure. It's not my specialty, but I think it alone is some reason to pause. I think Jobst has an interesting point about whether regulation is really serving Silicon Valley versus hampering them. Those are interesting things to consider. But I guess as far as these near-term concerns go, I'm with Stuart Russell that we do need something like a FDA for algorithms that like at least oversees and checks to see, like, yeah, this is maybe, you can debate whether FDA is overly regulatory or underly regulatory, but I think most of us agree something like the FDA is a good idea. And maybe not everybody, but I'm pretty convinced the FDA is a good idea. And I think something like that should be in place for algorithms. But I have more to say on much of the stuff about the more long-term worries. I don't know if you'd like me to.
Go ahead.
Let's see. Well, so I've got a few little notes here. I guess maybe the main point is, well, so one thing that Barry was talking about is how these goals, as we see them now, we're tempted to give goals in things that are easily measurable, like games. And in a way, that's exactly the point of the alignment worry, right? Is that there are goals, human goals are extremely hard to model correctly, the way humans are. Why? We've been shaped by, millions of years of evolution. We just have extremely complicated utility space, you might say. So that's the worry. Anything we're likely to pre-program with whatever hardwired goals is going to have something much more easily measurable. And that much more easily measurable thing, like smiles or like dopamine, or like, you can imagine more complicated, but it's going to take a long time to hardwire human-friendly goals in a way that actually is compatible with what our goals are. And this is what the alignment community sometimes calls a good hard problem, right? There's this old problem in economics that when your measure becomes the target, it ceases to be a good measure, right? As soon as you measure happiness by smiles and the machine sets out to maximize smiles, it's going to miss happiness by a mile, right?
Can I interrupt? So I think you really need to read our book, Steve. So we draw a distinction, categorical distinction between two kinds of systems. Simple systems like Go, or like other games like Go, on the one hand, where the computer can do very well, and complex systems, which are natural systems, like, for instance, your digestive system, and also partially artificial systems like the New York Stock Exchange. Now, we can make computers behave very impressively where it comes to simple systems, but human beings have the ability to navigate the world of complex systems, and we do it all the time. That's family life. That's what happens when patients visit doctors. That's what happens when people make plans about the future of a company or of a football team. They're dealing with complex systems, and humans can move from one complex system to another. And the complex systems in which humans inhabit change from moment to moment and from day to day. Unlike games like Go, where there is no change. It's always the same interactions. It's always the same elements. And so you're talking about modeling the kinds of goals that humans have when it's impossible to model the kinds of goals that humans have, because we're dealing with a very, very limited range of what the computer can compute. And we were talking earlier about Jobst's textbook of neuroscience. In order to be able to compute in the way that the human brain operates, we would need to...
An ant suffices. An ant, this insect.
Or an ant, or a bee, or a rabbit. In order to be able to compute like any of those organisms operates, we would need to have a quite different kind of computing, something that Turing machines can't do. And so this is why the subtitle of our book is AI, Artificial Intelligence Without Fear. There's no way in which we can have an artificial, even evil demon with powers of computing greater than the powers of human or rabbit or be intelligence. So there's nothing to worry about.
So I would like, Steve, before you answer, I would like to once go into the mathematics, because both of you also studied mathematics, right? And so we have in the book, we have we argue with thermodynamics. We say that that since Boltzmann, we know that physical systems can have properties thematically modeled. Like Boltzmann was the first to recognize himself. And I would just list three. The first one is that complex systems can change their element types. So then it cannot only change elements, like for example, the solar system as a gravitational system can be, it's not a simple system, but it can be approximated very well as what we call a simple logic system. And the sun can receive a new asteroid flying, circling around it. This can happen because a piece of matter comes into the gravitational orbit of the sun and then gets attracted and gets into a new orbit. So it can acquire a new element, but this system can't acquire a new element type. And complex systems can acquire new element types. So for example, bacteria can obtain toxins that they didn't have before, that had nothing to do with the way they operated before. The second one is that the very, very important one is non-ergodicity. So complex systems have phase spaces that are not non-ergodic. And I will say what this means in a minute. And they are driven. So they dissipate energy all the time and draw negative entropy from their environment. All these three properties can't be modeled mathematically at all, because what it means in mathematical terms is that the systems change their phase space all the time. But in mathematics, we're dealing with fixed phase spaces. So for example, ChatGPT acts in a fixed phase space. It's very big, but it's still a fixed phase space in which the parameterization takes place. And what's worse is the following. And this Boltzmann saw very clearly. Boltzmann defined ergodicity as when now this glass of water is empty, but if there's water in it, and I draw a bit of water anywhere in this glass, the likelihood distribution is the same everywhere, and over time, for each molecule that is in this water, is likely to be at any place, any coordinate in the special coordinate in the water is the same. And when you have such systems, you can draw samples from them, and then you can train an algorithm that models this space. And then when you draw the next sample, you can make very good predictions. And that's why the game of Go can be learned, or not learned, parameterized into a computer and so on. But when you have a non-ergodic system, you can't do that. And natural intelligence is always non-ergodic. That's its very nature. And that's what machines can never achieve. They can always only reproduce behavior that was trained very painfully and at very, very high costs into them if the behavior is sufficiently complex before. They can only be applied to regularities. But intelligence is irregular. That's the very nature of intelligence. So I think when you understand this, when you understand function analysis, how these phase space or vector spaces come about, what the nature of the functions is that act in them, how a function basically maps a certain input to a certain output, but the input and output space are always predefined, well, then you realize very quickly that all you can do is approximate in a limited way certain partial aspects of complex system behavior, but you can't approximate much more. And so therefore, it's not by chance that we are not getting anywhere near AGI. All we produce is yet another very good specialized application of mathematics, but that doesn't generalize at all. If you take it out of its context, it's immediately useless. And so it's only very specialized to a certain regular pattern. And wherever you have regular patterns, you can, of course, express them mathematically. And this is a great progress, the way you can, since the genre invented this in 1805, regression, there has been an incredible progress, and it's admirable. And I'm not saying, and I'm also pro-technical or pro-technology, and like you are, Steve, but I just see it in a very sober way. It's just mathematics.
But what if brains really aren't computers? I mean, what if you got the wrong metaphor for the brain, and therefore the wrong metaphor for what intelligence is and what can mimic what? I mean, there's this idea that, well, the brain computing comes out of it, but what's really going on there is a kind of an ecosystem inside the brain, in the body as well, and to what extent does this is this debate influenced by or constrained by our adherence to this metaphor of the brain as computer? Does it all go away if the brain is actually an ecosystem?
Jobs and I both embrace an ecosystem view of the brain, of let's say the mind-brain continuum. Mm-hmm. We don't think that human brains are computers. We think that's a mistake, and it's a very tempting mistake. But not when you kick the tires of ChatGPT just for a short time. You'll see all the absurdities that it produces. Mm-hmm. Mm-hmm.
I kind of want to. Yeah. Well, I think I'd like to say, for one thing, that ChatGPT in this context is a bit of a red herring. I mean, even Eliezer Yudkowsky, who's sort of the ultimate doomist, says, yeah, ChatGPT, we're not an immediate threat from GPT-4.
Yes, you're totally right. We agree on that.
GPT-20, maybe when it gets really good at token prediction and understands the world well enough that one way to get really good at token prediction is make humans create certain new kinds of tokens in certain sequences, then we worry. But that requires something like autonomy, which is its own issue. But when it comes to, I guess I'd like to respond about the complexity in complex systems. I confessed earlier that I haven't read their book yet, but I have read some reviews. I have some understanding of their position. And from what I understand, the weather system also checks all 7 of their boxes for complexity, and to be a complex system. And yet, clearly, we can model it.
The climate, and the long-term
climate, the global climate, yeah.
Yes.
But we can model both to some level of approximation, right?
Short-term weather in certain geographic areas we can measure quite well. That's a partial. So what happens there, that we have a simple model of a complex system that works in the short term quite well. But that doesn't mean at all that we are close to being able to model complex systems. And of course, it's clear we can't model the climate at all. The climate models are unscientific that we have.
The full model would be intractable. But the question then is, how much approximation do we need? At what level of abstraction? So, here's a little heuristic, right? There's a recent paper that they modeled, some lab modeled neurons in complexity down to the millisecond, 99% accuracy with 1,000 artificial neuronal nodes and 5 layers. So at some level of approximation, a computer can approximate very, 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 very closely what's going on in the human brain, in principle. Are we close to that now? No. But I'd like to point out that ChatGPT was a startling advance that took everyone by surprise, including the people working on the large language models. We don't quite know what fire we're playing with here. We shouldn't be super confident that this is very far off the right level of approximation, right? Where it seems to have the power that is worrisome.
So to begin with, we have 2 pages about GPT-3 in the book, where we describe exactly how it works. And we wrote this before ChatGPT, 1.5 years before ChatGPT became about. And I wasn't surprised at all by ChatGPT because I understand really well how LLM work. And so, and Jan LeCun also understands it very well. He also, by the way, he's the head of Meta AI. He believes, like me, that it's nonsense to say that AI will become dangerous. So we are not alone in this, But
Jan, I know Jan has that view, but let me put it this way. 10 years ago, would you have predicted that there'd be a system that could outperform humans on LSATs and GREs and APs and all these benchmarks?
I don't think that it outperforms humans at all. I think what happens is when you so let's look, for example, at a young student who finishes Harvard Medical School, right? And if you put him into there are written tests, that can be performed on humans to assess whether they have learned a part of the curriculum. And on this, ChatGPT is now quite good on parts of them. I agree with that. And despite it has no specific training on so on, that seems very impressive. However, the real test is, of course, the practical test where you are put in front of the patient, you have to examine him, you have to talk to him, then you can basically, that's how it's in German, request exams as if you were really forward what What happened? Can you still hear me? Hello?
Not very well.
Not very well. Yeah.
I'm sorry. I hope it's
I
better
think the
now.
point was,
So anyhow, so and then you need intelligence better.
You're still coming in and out.
Let me have a go. So
yeah.
I think I can
Yeah.
work out what Jobbs is trying to say.
Yeah.
First of all,
yes.
Gary Marcus has pointed out that we don't really know what is being achieved when these claims are made on behalf of GPT-4 in particular, because we don't know what the training samples were which were used to train GPT-4. And it could very well be that because this kind of information is pretty widespread, that a lot of it is in the web already, and therefore it's in the training material. And so this is just showing that GPT-4 has a really good capacity to extract its own training material and repeat it in relevant contexts. I'm a big fan of what it can do, but we have to understand it. And we don't understand this particular aspect because we don't know what the training material was. But what Jobbs was trying to say is that it's not the ability to do tests which is the real test. So it's easier to pass a Turing test when it's just texts which are being exchanged between one party and another. In the case of a doctor, the trick is to be able to deal with patients. And that's an ecosystem kind of affair and not...
Totally agree.
Good.
Sorry, my point about ChatGPT is not that it is going to be a great lawyer necessarily. All I was trying to say was that I think very few of us would have predicted that any system could perform on those benchmarks by hook or by crook the way they have now. And
Okay,
my point,
point taken, totally taken,
so,
Steve. I think,
but the bigger point is just that these technologies can take us by surprise and advance faster than we expect.
yes,
and we don't,
I agree. And the weather models are a good idea because in the 1940s, nobody thought that the weather models that we would get from the 70s onward would perform as well. So, and I'm totally not as naive to think that there can be no technical progress with regard to oh gosh, sorry, I have also children problem. I need to switch off my phone. My wife is not here, sorry. So it's naive to try to predict exactly how scientific progress advances and technical progress. The point is not whether these tools won't get better and won't we be able to use them in certain circumstances. All of this is certainly true. This is like the anti-industrial revolution. It has a tremendous impact on our life, and also we have to very carefully consider, you know, how to use these tools properly, what the abuse patterns are, and so on. So on all of this we agree. But the point is, will there really become autonomous actors who can form their own goals, pursue them independently of human beings? And this is what we believe is this aspect is we believe is infeasible. And the definitions of that are given by the AGI community to claim that there will be AGI, they're all self-fulfilling, because all these requirements can be fulfilled using utility maximizing functions, which is what we have been using since Legendre to create regression models, right? We've been minimizing loss functions since Legendre, but minimizing a loss function is equivalent mathematically to maximizing a gain function. And so if you take a pseudo definition of intelligence, of course you can then claim that the model can achieve it, but you are only putting in what you anyhow are sure to get out. But if you go back to the only intelligence definition that we have that makes sense, that it's a solution to solve problems spontaneously in a previously unprepared manner, according to one's own intentions. You know, that requires intention and the spontaneous ability to solve problems. Then that's where we say it's impossible, because that is a holistic property of the human or animal mind-body continuum for which we are unable to create mathematical models. But everything else, you know, creating specific models, even creating very dangerous AI-driven weapons and all of this. I'm completely with you, Steve, that this is, like many other technological developments, very dangerous, and we have to be. I also think we may need regulators for parts of this and so on. But it should be better if they wouldn't get into regulatory capture like the FDA went. But that's a different story. But basically, you're right. But this limit that we can suddenly create something that is truly autonomous, pursuing its own goals, this we think is impossible. but gradual improvements are of course possible.
Yeah. So we have a few questions starting to stream in. So maybe we could segue into the questions by elaborating on something that I think you said, Barry, and related to this kind of rent-seeking question that we tossed out at the beginning. I think you mentioned, Barry, that Bing and Microsoft are heavily involved in this kind of infrastructure where you have the 10,000 programmers and or people in Kenya who do this. Did I hear you correctly on that, or?
So I think you heard part of what Jobst had to say and part of what I had to say, and you put two and two together. But that's fine.
It is. But you know, there is this infrastructure and this stuff that goes on behind the scenes, and your comment about Bing resonated with me because Bing seems to barge its way into my operating system without being asked, and it's very aggressive about doing so. And if Microsoft and Bing are all part of this infrastructure of artificial intelligence and ChatGPT, is that where we need to start doing some regulating to sort of turf out this rent-seeking behavior on the parts of these big corporate players?
But then we shouldn't talk about AI ethics. We should talk about good old-fashioned human ethics. Mm-hmm. And so I think that one nice thing which the European Union did was to reduce the number of plugs that we have to carry around with us when we are using computers and headphones and so forth. I think that's the kind of step forward that we need. And not regulatory capture. Okay.
Steve, what do you think?
Sorry, about like near term. I mean, I
just think there's this kind of, especially in these days where we're looking for conspiracies everywhere, and you know, I sit there and wonder, why is Bing barging its way onto my desktop now? And then I hear that, well, Microsoft is heavily involved in pushing artificial intelligence, and Bing is somehow tied into that. You know, should that be where we're looking, trying to uncover some of these motivations of behind the scenes actors?
Certainly, I'm quite concerned about the motivations of behind the scene actors. I mean, one concern in the alignment community is that this is going to be a race to the bottom. That, you know, DeepMind and Google were reportedly panicked by the success of OpenAI and their large language models, and so they want to do it. And both these companies are relatively responsible. DeepMind and OpenAI, they have alignment teams, they have safety teams, they're working hard. The reason I think it doesn't pass the Turing test now has a lot to do with the reinforced the human reinforcement learning from human feedback that Barry was talking about. There's guardrails. Without those guardrails, I think it would be much more likely to pass the Turing test in a lot of contexts. Again, maybe not all, but it's not clear humans would pass in all contexts.
Yeah.
Okay.
So, sorry. Well, I lost the thread. It's the short-term thread. Sorry, go ahead.
Well, let's try to put it this way. You know, suppose we had, in addition to the three of you, we had Elon Musk and Bill Gates sitting in the room. Yeah. You know,
sorry. Yes.
How would you respond to them?
Well, so there's this worry about arms race, not just like between corporations, but also between governments, that if there's going to be an arms race for AI, this makes it that much more likely than if it's going to be done to the level of artificial general intelligence, which is a first step towards superintelligence, plausibly, according to many of us, not according to Jobst and Barry, but according to many others, AGI is possible and maybe even imminent, and a near step towards superintelligence. And if there's going to be a race for this, and if it can be successful, as I and many people think, the race is going to ensure that corners will be cut and that safety in particular will be cut. And this makes it all the more worrisome. And when it cut, one last point on this, it's not clear that it's entirely about profit. OpenAI is heavily invested in by Microsoft, but they have a very weird structure where the investment return is capped at 100%, and where Sam Altman has in his contract that he can shut it down at any moment he likes without anyone complaining. And Sam Altman doesn't himself have equity in the company. But there are all these other motivations, like he wants to be the guy, I suspect. you read a profile of him, and I forget whether it's New York Times or New Yorker or there's some profile of him where it just seemed clear that, everyone treated him as the new Steve Jobs, and he's a mover and shaker, he's ambitious. That might be enough to get us to a dangerous level of AI without even the profit motive.
So first of all, I mean, I completely agree with you, Steve, that if technology can be abused, it is always abused, right? So the Nazis have abused toxic cyanide in the concentration camps before, and atomic bomb has been abused by the United States during World War II. I think it will happen again. We have seen in SARS-CoV-2 that genetic engineering has been abused to make a virus more infectious than the natural variant. So I agree with you that humans will always abuse technology for evil means, and that one of the miracles that mankind still exists is because there's also control of this. But if evil can be done, it is usually done to some extent, and that has to do with human nature. And if AGI and superintelligence are technically feasible, they will be done, and they will wreak havoc, I'm certain. Yeah, it's a loose cannon, would be uncontrollable and very dangerous. The point is, we have to very carefully, and we do this in the book, look at how should this be done, right? And the people like Nick Bostrom and all those who argue that it can be done, none of them has ever looked at functional analysis. None of them. If you argue, so even if I discuss with physicists about this, and they say, oh, it's feasible, and then we come to functional analysis and explain them how AI is just a way of using functional analysis, then they say, gosh, I didn't think of that, I didn't know that, yes, you're right, oh, that's a relief. If you really look at the mathematics, you can't tell me how to do it. Nobody can tell it. All the ideas that Bostrom and all these doomsayers propose, they are mathematically invalid. It's not physics, it's not mathematics. And so if you want to convince me that it's possible, go ahead and argue mathematically. But if you do that, you will stop yourself and realize no matter what you review and what you learn about, what we call extended Newtonian mathematics, that it's impossible. I agree with you. If it would be possible, it would create it would be super dangerous, but it's infeasible, and that's the point, because there's no way to do it. And I think we live in an age where hype is cooked up about certain topics, and we have to very carefully as scientists look at, what of this can really be done using the tools of science and what can't be done. And so, for example, looking at viruses, people now panic about killer viruses being engineered. Well, you can engineer killer bacteria, but it's actually very hard to engineer killer viruses and so on. So you just have to know this stuff, how are things done, and then you can cool-headedly figure out whether it's likely. And if you look at the mathematics of computable algorithms, you just see that it's almost impossible, I think totally impossible, to create an AGI. And that's because you have only big equations. And these big equations are, in the end, they are even, differentiable and continuous. Nothing in the brain is differentiable and continuous. It's just a total mismatch of the models. And so that's the key point we are making. Otherwise, I agree completely with you. Under the premise that AGI and superintelligence are feasible, you're 100% right. So it's really only about the scientific feasibility of this that we have to discuss, because on everything else we agree. I want to make another side remark. I don't think we can solve ethics. Ethics has no solution. Ethics is also super complex and always different, but that's just a side.
Yeah, so one of the questioners, let's see if I can find it, ask this general question, is artificial intelligence moral? And of course, for that matter, is our intelligence even moral? Where does our morality come from? And this ties into another question that's kind of the snake eating its tail. If artificial intelligence, maybe I didn't quite get this. If we can't rely on artificial intelligence to be predictable in what its behavior is, can we predict even where artificial intelligence is going to go, and then what the appropriate regulatory issues would be? One of our questioners said, well, economies are complex systems as well, and so, what's the appropriate regulatory metaphor, FDA, the Federal Trade Commission, those kinds of things. So I wonder if any of you have any thoughts on that.
Barry, that would be to you.
Can we predict where AI is going to be going in the next 10 years, given that AI is itself a complex system?
Then, of course, not.
What's that?
AI is not a complex system.
Oh, okay.
The
Our intelligence
industry of creating AI,
Yeah, okay.
which is primarily driven by human beings, is a complex system, and therefore we can't predict how that industry will evolve.
So would regulations, a regulatory regime, do more harm than good then, if we can't know where it's going to go?
I go back to my point a few minutes ago that even if we in the West embrace a regulatory system to assuming that is needed, then it's very likely that some other countries will ignore it and do what they want.
I would like to highlight that, of course, the process of creating AI is highly complex because complex systems are interacting with complex systems and so on. But the AI itself is always a logic system. It runs on a Turing machine. With the Turing machine itself can only compute a tiny fraction of all possible algorithms. So it stays a logic system. As to regulation, I think we need regulation of applications, or we may want to have regulation of applications. So give an example with which I'm certain Steve will agree. So if we think of AI-driven weapons, we now have loitering munitions already, which are very, very destructive and very hard to control. And so like we have at the moment international treaties to prevent the use of chemical and biological bombs, and also in warfare, and also to somehow ban the usage of nuclear bombs. So they are interestingly less banned than biological chemical weapons. We can also imagine to have international treaties and regulation around the usage of AI in certain circumstances. That's one important aspect of regulation. The other important aspect for ethical reasons, and the other important aspect is regulation to prevent oligopolies or monopolies, which has always been, since modern capitalism developed, a big problem, which we saw for the first time in the 1910s and 20s, when huge monopolies had evolved in the US, that were creating incredible rent incomes for their owners, and the population of the US was suffering. And so we need to regulate these monopolies, which have already formed in AI, and of which I think Steve, in how he described OpenAI and Microsoft, gave a great account. People become megalomaniac, they extract huge rents, robber baron-like rents, and so this is an aspect I think where we need regulation. Otherwise, we lose the market. And without the market forces, there is no self-regulation anymore. And so for me, these are the two areas. Using AI to kill people or for other evil means needs to be regulated, and the formation of monopolies needs to be regulated. Otherwise, I'm against any regulation because it inhibits creativity, it fosters monopolies actually instead of preventing them, and also is not required because we have nothing to fear from the technology itself, only from its usage.
So a couple of the listeners framed some questions kind of like this, and I'll just read from Ken's in the Q&A. This is tied into manipulation of public opinion, especially around elections. And of course, everyone is very tuned into that. So he asked, should we be concerned about the power of AI to simulate statements and visual messages of political opponents, kind of a deep fake kind of a thing, thereby influencing elections more than in the past? So are these going to be political players or political tools, I suppose would be the better metaphor? To what extent do you think that will happen?
There are going to be human beings who are determining what happens on that front. And the AI is powerful in all kinds of ways. People have already found ways of using AI to influence elections, and they'll continue to do so. But that doesn't mean that the AI itself is somehow evil, or that the AI is making choices for this or that political party. The AI systems don't have goals of that sort. They can have very simple goals because of the ways we train AIs to play games and do other simple exercises, but we can't train AIs to have political goals of their own. That doesn't make sense.
But it can certainly be tools in the hands of people who do, right?
Absolutely, yes.
Yeah, yeah. So
and they are going to produce. They're going to be used in good ways, and they're going to be used in bad ways. That's that's.
Steve, yeah.
So I wanted to jump in a bit on the goals thing, not so much because of the, I mean, I'm somewhat worried about misinformation. We haven't quite seen it in the wild to my knowledge, but Daniel Dennett just posted something to The Atlantic about how, like, seriously, we should take the idea of impersonating intelligences. And I think that's important. But I guess when it comes to goals, like, this is something I've been working on for some time now, because this notion of goal is very tricky. And it's another place where we're tempted to make ourselves special. Jobst talks about autonomy, and I think the way I hear you talk about autonomy, it's very like the old Lovelace objection. Either there's a trivial sense where computers can rewrite their own goals, or there's a sense where they can't, but neither can we. I came into existence with certain goals that I had no choice over. Now, I can choose to stop eating if I want to free India or something like that. But I still came into existence with goals that were handed to me, and then I navigated the environment based on those goals. And then of course I can change my instrumental goals along the way. I can measure some against another. There's a complex equation, and I agree that's the way humans do it. It's very, very complex, which is basically the alignment problem. But I think it sounds to me like the Lady Lovelace, like, well, they're just programmed and we're not. There's an important sense. You have to be very, very clear on these slippery words like just programmed and like autonomous. And so I've yet to hear.
Even programming a goal is a very complex thing. And we're arguing quite literally that the only kinds of goals that we understand in machines at the moment are the goals created by the sort of reinforcement learning that you see when you create. But let me just say one thing that you mentioned, Yudkowsky. If you read the passages in Bostrom's book on superintelligence, where he deals with goals, he apologizes because he says the best he can do when it comes to specifying how an AI could have a goal is, and then he quotes some passages from Yudkowsky apologetically, because they're absolute nonsense. What Yudkowsky says is, the goal of the ultimate future computer will be a goal of all goals, which will be the extrapolation of human goals, the goal of the best of us in the best of all possible circumstances, and so on. It's absolute nonsense.
So a couple things there. One is I think you're talking about what Yudkowsky calls the coherent extrapolated volition.
Yeah.
Which is not, I don't think it's nonsense. It's basically just Railton's like idealized observer theory, which he kind of acknowledges later. But that's not Bostrom's gloss on what goals are. I mean, what goals are, I agree, is
goals that would be programmable inside a machine.
Well, he wants that, like, goals that might be human friendly. It's easy to program goals in a machine if you take a behavioristic notion of goals, where, like, win this Go game. And now, as you acknowledge,
we agree. In games, you can do it.
So in other words,
you can do it generally.
Yeah. So in other words, there are certain easily measurable, easily specified goals. They won't match human goals, but they're easily specified ones. And the point of, like, Bostrom's paperclip maximizer, which is an ancient sort of joke by now, but the point of that is just that there's a fairly easily specified goal. And if you want it more specifiable, just think in terms of, like, diamond lattices. Like, that's something that'd be fairly easy. Diamond lattices of carbon in the right arrangement. That's fairly easy specifiable. That's fairly easy to detect. Imagine an enormous intelligence that genuinely only cared about maximizing that.
Yeah, but you always assume that there is an intelligence or a will or both.
I mean, whether you want to call it a real will, whether it has real values or whatever, it's
no, it's not about being real. It's about being able to perform the following. I repeat myself again. A novel situation never experienced before.
Yeah.
Be able to react to this novel situation in a way that is in alignment with the intentions. So, and this is there is no way to tell me how to get to this mathematically, because mathematical algorithms are always concerned with repetitive patterns. But what I've just described is not repetitive. So we can do away with autonomy, with goals, and all of these terms, and only concentrate on the ability in a novel situation that was never encountered before, without any training and further experience related to this, to find a solution. And this is mathematical. You can't describe to me how you want to achieve this mathematically.
Sure. I mean, we can. So, I mean, look, yes, I basically agree that one way to characterize intelligence is something like out of distribution behavior. In other words, you were trained on this one distribution. Can you still manage to achieve your goal out of that distribution with things that you have not seen before? Now, there's a clear sense where already AlphaZero and so on has achieved that very well. It wasn't trained on the exact games it played with at least at all, but it still managed to win. It was in one important sense out of its distribution. Now,
that's not true. That's actually not true. So it was trained.
It was not trained on the exact game they played.
No, it was. It had then. If it was wanted to play a new game, it had, of course, it used the existing stochastic model was used and was adapted to the new situation, and you achieve this by letting it play this new game, and by basically allowing reparameterization of the model based on this. And so if you do that, of course, you can readapt the model. If the model is very powerful and the situation in which you are use the model is extremely restrictive, and we call this a closed world in computer science. And all these examples you're pulling out come from a closed world. We haven't even discussed the problem of perception yet.
But
right?
Okay, sorry. I mean, again, I think there's a clear sense where the whole problem of abduction is just trying to generalize, trying to find patterns and generalizing them to cases you've never seen before. This is something that's very hard, but that we're making progress on. And one sort of proof of concept is the Solomonov style induction, where you just take all possible probability distributions that are responsible for the data you see, and update them Bayes style, and adjust the weights as one putative probability distribution succeeds and another one fails. Now, this is intractable, of course, but it's something that we can arguably approximate with things like minimum description length algorithms.
So this is of course refers to ergodic systems. And I agree with you that if you have ergodic systems that create distributions which have not maybe the Markov property, but a weaker form of regularity, then you can find local optima to model these distributions and the process that generates them. I agree with you. But
Solomonov will work on any computable distribution.
What?
If you're claiming that Solomonov will work on any computable distribution, your model class is computable distributions. Now, if you're claiming that like the distribution that we managed to model is incomputable.
Yes, many distributions in the real world, 99.9% of all inanimate systems in nature have distributions that are non-computables. For example, turbulence is a very simple one. So you smoke a cigar, you look at the plume that goes up from the cigar, it's an uncomputable distribution. It's non-ergodic.
Yeah, of course. So all that means is I have to approximate it to a relevant degree.
Yes, and with turbulence, we have mathematically, it has been shown that it's impossible. Heisenberg said, when I die, I will ask Peter or whoever is in heaven two things: how does general relativity work and how does turbulence work? And I'm certain that God will be able to answer the first question. I mean, it's just it's you know, it's out of range of mathematical modeling, and turbulence is just a tiny phenomenon within complex systems. And we have no chance of modeling this because every microstate we measure at any point in time is different from any other collection of microstates at the next moment. That's the nature of non-ergodicity. And so if you say artificial intelligence is feasible, then you're telling me basically that you can model non-ergodicity. And then it's like saying, I can win against the second law of thermodynamics, you know. I think it's just, it's not serious, this whole, because nobody has ever been able to tell me how you want to overcome thermodynamics.
I can't model at the microdynamic level, but I can predict enough about smoke to know how to stay away from secondhand smoke. I can do it to the approximation level required to achieve my goals most of the time.
Human being, yes, because your complex system have natural intelligence.
Why in principle would a robot not be able to make those same kind of abstractions?
So first of all, let's talk about robot perception, which we haven't done. So in the book we show, we talk about active perception, right? Which is one of the few contributions made by an American philosopher, which were in the history of philosophy, which were really original. Charles Sanders Peirce, right? Or Pierce, or how you pronounce him. And he said that, Barry could also elaborate on this much better than I, but he basically found out that motor perception is active, and that you have a constant circuit between movements and the sensory input that gets readjusted. We have no idea how to model this, and the way we model now computer perception is super primitive because it can't model the circuit. That's also why we don't find a way to model fine motor movements, where you also need.
I think active inference is a great model, and it's thoroughly computationally tractable.
Which one?
Active inference, Carl Friston's program.
I'm not talking about active inference, but motor sensoric circuits.
Yeah, those are part of active. That's part of active inference. You predict where the.
I don't think so. I think it's much more.
I mean.
So the questions are coming in quite thick and fast here, and I'm going to try to summarize some of them. I'm sorry we can't get to all of them individually, but if we don't get to your specific question, please do send them to me by email at turner@nas.org. But let's have a think about this. There are several people who have said, well, okay, computing and mathematics might not be okay now for this, but who's to say it's not going to be in the future? Someone brought up a common thing that goes on in my field, this idea that scientists used to think that bees would not be able to fly. And of course, they do fly, and the failure was in us not really understanding it. And another person asks, okay, so if it's going to develop along certain lines, okay, it might be fine, but how will we know when it's crossed a threshold into being something dangerous?
So I can have a go at the first one.
Okay.
So we when we first published the book, actually when we were first presenting the ideas in the book, we presented them to audiences of AI people and to other audiences, and the AI response was very often that there have been so many predictions of impossibility in the history of science and technology which proved wrong. And therefore, any prediction of impossibility in science and technology must be wrong. That was the basis of the argument. And of course, no one collects all the predictions which were proved correct, except one, which is the prediction that there will never be a perpetual motion machine.
Yes.
Now, somebody could say, well, maybe our ideas of physics or mathematics will change and there will be a perpetual motion machine. But no one would take such an argument seriously. Now, we believe that the properties of Turing machines and of Church-Turing computability place limits, quite severe limits, on what any AI system could ever do. And we've tried to specify what those limits are. And ChatGPT does not threaten our specification in any way. And so we say, sure, mathematics and physics, the physics of thermodynamics and so on, they may change in the next 100 years, and then we would be shown wrong. But we're not holding our breath.
Steve, do you have any thoughts on this threshold? How will we know if we have crossed a threshold?
Oh, well, that one, yeah, that's part of the worry is we won't. I mean, that's, again, I think in certain respects, a lot of people were taken by surprise by what these LLMs can do. Again, I'm not claiming they are general intelligence. That depends very much on what the bar is. But the point is that technology does have a way of surprising us. And of course, there are predictions that I'm also likely to think that no one's going to get faster than light technology or a perpetual motion machine or defeat the second law of entropy. But it does give us, some reason to pause. I mean, again, I'd be interested to see like a survey of mathematicians and physicists, but it's worth saying that the AI experts, maybe because they're too mathematically, physically ignorant, but I wouldn't totally bank on that. They tend to have pretty good grounding in those fields, and they seem to think it's thoroughly plausible and thoroughly possible and maybe even coming soon.
So I'm one of them. And I've been there for 25 years, like many of the people I know. And I think that also in computer science, many people, roughly half, disagree. But it's never about how many disagree or agree. Look at Galileo Galilei. Nobody agreed, but he was right. So I think I would like to answer more the point of Scott. So where's the limit? I think the limit is in the way we construct mathematical models. They are always happening in a phase space with predefined dimensions. The dimensions can't change, and if we are unable to capture something that is happening within those dimensions, the models will fail. And this is very, very fundamental mathematics. This wasn't changed neither changed when infinitesimal mathematics were invented by Leibniz and Newton. It wasn't changed when Euclidean mathematics were overcome at the end of the 19th century, and Hilbert invented the Hilbert space, or the manifolds were invented by
Riemann.
Yeah, Riemann, thank you, and so on. So this never changed. So I think that mathematics has a very stable core and a very stable infinite dimensional geometry in which all of this happens, and that it is based. Mathematics is based on identifying regularities, and nature creates irregularities, and that's where I see the core difference. And yes, mathematics will evolve, but I don't think so radically. But maybe somewhere else in the universe, people have already created artificial general intelligence. I don't know, but I think it's highly unlikely.
So one of our arguments for our position is precisely that there are no UFOs.
UFOs, yes.
If AI was possible, then it would have been created on many distant planets, and they would have the power, the super Bostrom power, to send satellites to Earth, but we don't see. Therefore, we're correct.
Yeah. Well, we've reached the end of our time, friends. This has been a fascinating, lively discussion. It could go on for hours, but I think I'm going to give the last word to one of our commenters in the chat, Gregory McNiff, about the threshold problem. He says that we'll know when the machines start shooting at us, and so I hope we recognize the danger before it gets to that point. So, Steve, Jobst, and Barry, thank you so much for a wonderful, lively discussion. I really had a great time. And several of the people want you to do some more work to summarize your discussion. I'll try to do my best on this end, but I may be in touch with you later. So on behalf of the National Association of Scholars in Restoring the Sciences, thank you for coming all. And we will see you in our next episode. Good day.
Thank you very much. Bye, Steve. It was nice to meet you.